audio amplifier circuit. So in this topic you are going to design audio amplifier which is low power and cost effective, and we are going to give a solution for amplifying a low level signals into amplifying the high level signal. So in this you are going to consider the challenges such as signal distortion, noise, and also power management, and also cost of the amplifier circuit. So for these challenges, give a solution for this audio amplifier circuit.
We are going to present a case study on audio amplifier circuit, which is low power and cost effective. It is suitable for smartphones or headphones with low power. There are several types of amplifiers. Overview of the circuit. Types of amplifiers: Class A or Class AB analog amplifier. Key components: transistors or op-amp. Example: LM386 or TL072. Biasing resistor for transistor operations. Feedback resistance, load, and the power supply. Power supply used in 9 volt DC. Load 8 ohm smart headphones are used.
In the audio amplifier circuit, there are 5 design considerations. They are input impedance, voltage gain, frequency response, distortion, and finally power and heat. So in the input impedance, the amplifier should not take much power or more power from the audio source, so like mobile phones and the media players. In the voltage gain, the small sound signal must be needed to made higher, because in the voltage gain, the small sound signal needs to be made very stronger to run a speaker. And in the frequency response, it should handle all the signals from lower bass to the higher treble. In distortion, the sound must be very clean and very neat. There must not be any noises from the other parties. And in the heat and power, too much heat can cause the amplifier to be worsen and make the sounds worse. So all these considerations must be considered very properly to design a proper audio amplifier circuit.
We discuss about a prototype design in LM386 for audio amplifier. In audio amplifier, the IC is used LM386 and its power supply is 9 voltage battery, and input gap is used in power is 10 nu F, and output power is used in 220 nu F with block the DC power, and its gain cap with pin number 1 and pin number 2 gap between, and pin number 7 is reduce the noise reductions, and speaker value is 8 ohms.
The challenges faced during development are signal distortion at high volume, power supply noise, oscillated and unwanted feedback, limited bass response, and heat generation at output storage. So the solution are given like in signal distortion we can reduce the gain, and in power supply noise we can add capacitors so that noise are reduced in power supply. In limited bass response we can add more capacitors, and in output storage we can add and use the shield audio cables, and last, the oscillated and unwanted feedback we can reduce the capacitors. As the result, the gain are 200 times better, and the distortion is under 1%, and the output was about 5 watts, and the sound are clear and balanced.
Recommendations for future improvements in audio amplifier circuit: switch to Class D amplifier for better higher efficiency. Use a operator amplifier prime stage for better input conditioning. Design PCB layout to minimize sound and crosstalk. Use a tone control circuit, bass or treble adjustment.
So I am going to conclude this topic, design of an audio amplifier. So the design of an audio amplifier, it is very simple. It is present multiple challenges, especially related to power management, distortion and frequency response. A component is chosen selectively, and it is effectively feedback.
So we have discussed a case study on audio amplifier circuit. So in this we have given a solution for low power cost effective for audio amplifier circuit. So we can improve the input impedance, voltage gain, frequency response, and also we give solution for power management and signal distortion. So by applying these concepts, we can give a better solution for audio amplifier circuit for loudspeakers and also our smartphones. Thank you.